artificial intelligence is great, but a combination of human intelligence and artificial intelligence, I think, is an even better combination for most applications.
Welcome to the LabVIEW experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes. I'm here today with Jeremy Pearson, and we are going to talk about doing vision applications in LabVIEW because we haven't really talked a lot about that on the podcast yet. So, Jeremy, why don't you start just with a little bit of your background, and then we can get into talking about some vision stuff and some of the interesting projects that you've worked on.
Great. So my name is Jeremy Pearson. I'm currently a LabVIEW consultant, but I'll just tell you a background of my career. In 2013, I started getting a master's degree in biomedical imaging technology at Texas A&M University. And that's really when I really started getting into LabVIEW development. I used LabVIEW to program machines that used lasers to perform 3D scans of biological tissue. And that was really fun. We just for testing purposes, we scanned a lot of little tadpoles, and sometimes we'd scan our fingers or other things like that, and it created three-dimensional images.
Is that similar to LiDAR technology for cars? Is it basically the same idea?
It is similar. This technology was called optical coherence tomography, and it's used for small things. So LiDAR is used for really large objects.
Mm-hmm.
It's used for small objects. It's kind of like on the border of microscopy.
Ah,
And so that interestingly, that's a technology is used very commonly to perform scans of your retina. So if you go to an ophthalmologist and they think that you might have a disease in the back of your eye, that's what they're going to use to scan your eye to see if you have to see like macular degeneration or some other kind of disease. So after that, I got a job working for National Instruments, which what it was called at the time. And I worked for the Vision and Motion Applications team, back with the good old engineering program, if everybody remembers that, right? Did that for 2 years, had a blast, learned about a whole lot of great NI products. I got a lot better at LabVIEW programming while I was there. Then I left NI to go work for an NI alliance partner that was located in the Philadelphia area. Back then, they were called Coleman Technologies because they were owned by Michael Coleman. But then when he sold the company, they changed the name to Sciotex. Great company. They're still around, still great company, doing a lot of LabVIEW work, a lot of vision systems. I only left that company just because I wanted to be closer to family out here in the Southwest United States. While I was there for 6 years and did a whole lot of vision systems using LabVIEW.
yeah. I feel like having experience working at NI and then having experience too doing some sales type roles, I feel is very useful when you set out on your own because the skills are the context that you get from working for with NI and like the knowledge of the products, and then also just the general sales skills. They don't really teach that coming out of college much.
Yeah, you really have to get your experience. So while I was at Sciotex, then simultaneously I was a LabVIEW developer and did a lot of really great fun projects there, especially with the focus on vision systems. But then I was also the director of business development. And so, I did all the sales work, talking to potential customers, negotiating contracts. And then it really is a skill, learning to keep track of potential opportunities, following up with them, also learning how to define a scope and negotiate a price for that scope. I think it was invaluable, and I'm really glad that I did it. There, that company had lots of employees. Well, I say lots. There was like 12, but I think that's pretty for consulting. That's a pretty big company, I think. Uh, Interestingly, I was the only person at that company that had any interest in doing any sales work.
Hmm.
Nobody, I guess engineers just say, I don't want to have to talk to people, right? I'd rather just program. But I didn't mind. I actually thought it was great experience, and I really appreciated the opportunity to do that. But then, for family reasons, I moved out here to New Mexico, and now I run my own company.
To your comment about engineers not being interested in sales, I I think that it's very valuable as an engineer, even if you're not directly interested in sales, to actually like talk to the customers. And I feel like it makes you a better engineer when you can when you can understand what their problems are. And I feel like sales is a lot of that.
Yeah, absolutely. So, as an engineer, anytime you get that customer facing, that interaction and everything, I think it's going to result in you being a better engineer.
Yeah, because like otherwise you're just kind of designing things in a vacuum.
Yeah, you really need to know the purpose behind the things, and also uh, engineers need to learn to define scopes that make sense, like, and this is famous, Elon Musk has said this, and that don't set stupid requirements, and I think you really get that by talking to people. You got to talk, well, hey, you've got this requirement. Why do you have this requirement? Let's Is there something better or a better way we could define this?
Yeah, what's the term for this? Like an XY problem, you're trying to solve X, but what you really want to do is Y or something like that.
Right,
Yeah.
right.
It's
So I
it,
loved it. When I was in sales, I loved it because I had a whole bunch of inbound inquiries, and I was the first one that got to talk to these people. And some of these things were just crazy, you know. And we didn't always do business with every single one, and sometimes they were just laughable. Like the one time I got a call from some guy at a Buddhist temple. So yeah, he was like a Buddhist priest, like in New York or something like this. And he said that he wanted a vision system so that he could like do some like astronomical tracking in this like Zen garden thing that he had. And he had like a telescope and he wanted to have some like custom cameras and software to do this special thing. And great guy to talk to. I told him this is just a little unusual. We don't usually have these kinds of inquiries. And then once he realized that it was going to be quite expensive, then he said, "Oh, this is not for me. We can't do this." So
yeah, I was immediately thinking budget is probably a concern
yeah.
there.
So I asked him how much he was expecting to pay, and he was in the hundreds of dollars, and I'm in like the tens of thousands of dollars minimum for this, and he was like, "Oh, we can't do it." So really nice guy, but I would get stuff like that all the time, and it was fun because I'd get off the phone, and then I'd tell all my buddies at work, "You're not going to believe what this one was about," and we always had laughs about all the inbound uh, inquiries and things that came in.
Were most of the inbound inquiries like a larger problem statement like that, or sometimes did they come and be like, "We need to measure X, Y, Z," and you're like, "Well, why do you want to measure it?" And then you had to like expand out to the problem.
Oh, all the time. Yeah. Whenever you had that initial conversation, they always phrased the conversation really strange ways. Like they were so fixated on like one specific thing. And what as I would talk to them and I'd just listen, after a while I'd be like, wait, why are we talking about this thing? Like, shouldn't we talk about the more broad issue that you're facing right now? And sometimes it wasn't until like the second or third conversation, like the follow-up sales call, or sometimes it wasn't until I was like talking to that person's boss before we actually got to the root of the problem.
Yeah, sometimes in consulting, people are like, "Oh, I really want to learn unit testing, or I really want to learn CI/CD stuff," and you start like digging in, and like you figure out that like they're not even like using source code control yet, and so it's like, oh, let's scale back the ambitions and start with the basics first sometimes. And I feel like that's a similar thing of like they get fixated on something because they read something somewhere or they somebody told them, oh, this is what you need to solve your problem, but they forget about the problem. They start pursuing that one thing.
Mhm. Now, what's interesting is if they would call in about a vision system, then almost always the conversation would move on to like we have to see this thing that you want to image. Like you got to give us some samples. And people would mail me stuff, and I had this shelf in my office with just like hundreds of different of junk, hundreds of different samples of like um, crazy things like candy, lots of nuts and bolts and little hardware things, electronics. Oh, blenders too. I had a guy send me like three brand new Ninja blenders because he wanted to do like some automated inspection of like the display. And the
Oh,
thing is like the guy, after he sent me these blenders, I was like taking a look at it and we were starting to like spec out the project and like start talking some prices and things. And then that guy, my contact left the company. He left Ninja.
hmm.
So then I called up his replacement. I'm like, hey, we were going to do this vision system, but you still want to do it? And they're like, oh yeah, we decided we're not going to do that anymore. And I was like, well, what do you want me to do with these blenders? And they're like, I'll just keep them, right? And so yeah, yeah. And so like we just like had all these blenders in the office, like really nice.
Margarita parties all the time or something.
So anyways, like all my shelves were just full of all this junk from like crazy things that people would send in. Um, so yeah, with vision, like a lot of it, you can't really solve the issue until you see what it is, you know. So we would the procedure would always be the same. Like send us some samples, send us some that are defective and some that are not defective. And then the ones that are defective, show us like show us like a whole um, give us a whole tour of all the different types of defects that you might see, right? Because like we need to be able to see everything that we're looking at. And then the rule of thumb that we had was if I, as a human being, can look at this and I can tell that it's defective, then probably there's a way to get the vision system to also be able to tell that it's defective. But if as a human being, if I look at it and I can't tell the difference, probably there's no vision system on the planet that could see that. Unless there was like some special modality, like maybe under ultraviolet light or different wavelengths or different imaging modalities, maybe that would make the contrast show up. But occasionally we'd have people that would send us samples and they would say, "Oh, there's this like little microscopic little crack in here. You can't even see it with the human eye, but uh, if you had a really advanced vision system, they can pick it up." And I'm just like, nope, nope. Like there's some modality that allows you to see the contrast in that thing, there's no way that we can see it either.
Did you ever do any dye penetrant testing? Would that help with some of those small cracks, maybe? Because I
Yeah,
know like they do that a lot for certain things.
yeah, absolutely. So that is an option. So you can add contrast with dyes. Um, a lot of times, if they're doing dye penetrant, they're not doing it in an automated way. They're
Hmm.
just off the the assembly line.
Hmm.
A technician is just putting in the dye and then just looking at it himself. So I've never done an automated dye penetrant inspection machine.
Yeah, I've only ever seen it for like cranes and stuff.
Yeah,
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 it was always manual.
yeah. But um, we did a lot of really cool and crazy vision systems, and all in LabVIEW, by the way. So um, we did a whole lot of consulting for the Howard Hughes Medical Institute, which is, a world-class research institute that focuses on studying brain tissue, and they're really trying to understand what makes brains work. And they study diseases of the brain and also how the operation of the brain. So I personally did work on a whole bunch of these light sheet microscopes. Um, it was so much fun, and also so it almost felt like a mad laboratory, mad scientist laboratory, right? So they would take brain tissue. Sometimes it was from like a fish or a mouse, or sometimes even like a human cadaver. And then they would mix it with these chemicals so that it would go kind of transparent. And then we would shoot these lasers through them in like kind of like a sheet of light. And
Hmm.
then that would illuminate all of the brain cells within that sheet. And then we take a picture.
Hmm.
So then they would move the sheet over a little bit, and then we take another picture. And then we'd keep doing that until we got like the entire volume of that brain sample, that tissue sample.
So you're making like a 3D scan.
Yeah, so it's a 3D scanning modality, but it has very high resolution and it produces the 3D scans very quickly. But the downside is that you have to clarify the tissue. So you have to mix these chemicals in it to make it transparent. So you can't do it with living tissue.
That was going to be my question. Yeah.
Well, and then, I don't know if I want to say you can't do it with living tissue because there were a lot of people there that were doing a lot of really crazy and really awesome imaging tools. So there might be a way that you could do it, with living beings. Um, Maybe if they were small, it might work. Um, so that was a lot of fun. That actually was a right up my alley because of my degree in biomedical imaging. And I did consulting on that for several years. Uh, we did a lot of other things. We had these people come in that worked for a company that made equipment for the nuclear power industry. So they said, we can't tell you exactly what we're going to use this for, but we've got these little ceramic pellets that are about the size of a cupcake sprinkle. And sometimes they have like little scratches or little surface def defects, or sometimes they're kind of curve shaped a little bit and they need to be straight. So we would like an automated inspection system that one by one inspects every one of these little pellets. And so my first question was, are they radioactive? Because I don't want to get zapped. And they
Yeah, that also probably affects what type of camera you choose and stuff too, right?
well,
Or
yeah.
electronics, yeah.
So and this has been several years, so NDAs are elapsed, and I don't even work for Sciotex anymore. But so they said on this system we're not going to be using radioactive pellets, but we can't say any more. And I was like, whoa, oh, is this like secret? We're not allowed to talk about this. So anyways, I think they used some kind of like analog to the actual part they were going to use, or maybe they were giving us the parts like before they were irradiated somehow. I don't really understand. I'm not a nuclear engineer, but I just thought that was a lot of fun that they were being like really cloak and dagger on us, like, oh, we can't talk about what these actually are. And so in the contract, we actually wrote it down. The parts were defined as ceramic pellets that are similar to cupcake sprinkles. That was in the
That's funny.
contract. So,
That
uh,
story caught my eye because I used to work for Westinghouse. They make nuclear power plants and they do fuel rods and stuff. And we had a heck of a time. I was not directly involved in this project. It was somebody I worked with, but they were trying to inspect nuclear fuel rods, which are these big, long, think giant cupcake sprinkles because they're probably about, I don't know, an inch or two wide and like 15 feet long, or I don't remember exactly how long they were. But these big long rods, and they're shiny and they're metal, and they were trying to find cracks in them. And they had tons of issues, and most of it was had to deal with lighting and just glare and reflection. I don't know if you've run into
oh
anything
yeah,
like that, but yeah, it was a
yeah,
really. I mean, they worked on it for years, and I don't think they ever actually figured it out.
really. Ah, that's one that I wish I could get involved in. Um, because that's a common problem, like proper illumination of the part so that you don't have the glare or other things. It can be really hard. And there are some techniques that you can use.
Yeah,
Um, yeah.
I,
And it takes some know-how.
Yeah, I think that was part of it. Like the guy who was working on it was a bright guy, but I don't think he was specifically like an optical guy or a vision guy. And but they played around. They all kinds of different ring lights and different ways to try to eliminate some of the glare.
Yeah.
But also like the cracks. To your point earlier, the cracks they were trying to find were pretty small too. So they're really like hairline cracks that are kind of difficult to see with your naked eye to begin with. So
Yeah. It can be really challenging. I mean, there are a lot of vision system projects that just don't work out. Like you'll start trying, you'll give it your best shot at trying to uh, find the defects. And one thing I've noticed is a lot of times it's pretty easy to create a system that can find the defect 90% of the time. But then you got to put in like 5 times the effort to go from 90% accurate to 99% accurate.
yeah, one of the projects I worked on peripherally was something to do with pills, and they were like dispensing medical pills and medication and supplements, and definitely trying to pick those out was interesting. That's one of those spots where like I don't even know if they would have been happy with 99%, depending on
Yeah.
the
Oh,
application.
yeah.
Like, yeah,
I've had a lot of customers that say we need like 99.9%.
yeah.
And I'll be like, okay, but just know that the cost rises very quickly, you know, because it takes a whole lot of effort to add an order of magnitude increase in accuracy. And another thing I point out to them is when you're adding additional accuracy requirements, we have to do a whole lot more testing to prove that. So if you only are going to allow one defect in 1,000 to, or you only allow the vision system to make one mistake in every 1,000 parts, then we're going to have to perform the test with, like 10,000 parts.
Hmm.
And if we're doing it one at a time, just the test alone is going to take weeks to do, depending on the speed. So, when they look at it that way, they're like, oh, okay, now I understand why the price is going up so fast.
Yeah, yeah. I mean, I wasn't even thinking about the testing, but yeah, the testing price would go up, but also just being able to get that level of accuracy itself is hard.
Yeah. And I like trying to steer the customers in the direction of let's get the system in place in your facility, and then we'll just gather data in your facility in line. And a lot of times these facilities are doing tens of thousands of parts a day. So let's just get all of that data in a huge database. And then based on that, then we can refine the vision algorithm, even throw in some artificial intelligence in there too. And then let's see how accurate we can get it that way.
Actually, that was going to be a question. How much of what you do in vision stuff is artificial intelligence nowadays? How much is just straight regular algorithms?
Great question. So um, a lot of what we do is still conventional machine vision. Uh, Machine vision is it's just the process of taking a digital image and then performing some analysis on that image to extract data. And that's really been around since the 1980s. Um, and it's pretty old technology. It still is fascinating and mesmerizing when you see it work, and but it's been around for a few decades. Um, so you do image processing to take the data in the image form, and you'll analyze the pixels, and then you can extract data like the size of an object, colors, if an object is present or not present, or if there's some kind of contrasting uh, object that usually doesn't appear. Like a scratch hopefully would show up as a dark object on a white background. And so that can be picked up with conventional machine vision. Now, machine vision lends itself very well um, to machine learning. And so actually some of the first applications of machine learning were actually in vision systems. And so really this machine learning, or really it's a deep learning now is the big hype, the large language models. Um, I mean, that really has it only been about a year or so there's been a lot of hype about that?
It's been maybe 2 or 3 years. It's not that long. Yeah, like the Chat GPT, I think came out 2 or 3 years
Yeah.
ago, maybe. Yeah.
So my first exposure to machine learning was years and years and years earlier than that. And so, I created my first neural network in order to do artificial intelligence analysis um, way back several years ago. I can't remember the exact year, but the first time was when we were contacted by the Hershey Chocolate Company, and they said that they wanted a machine. They wanted an operator to pull a bag of Halloween candy off of the conveyor and cut it open with scissors and then dump out all of the candies on a table. And then they wanted to be able to take a picture from the top. Okay. And we're outside the NDA period here, by the way. So I'm not violating anything here. But they wanted to take a picture of all of the candies on the table. And then they wanted the computer system to identify each individual candy and then count every one of them up. So that way they make sure that the right number of candies are in the bag and that there's a good distribution of different types of candy. So you're not ending up with, all Snickers or something, right?
Hmm.
So I created a proof of concept demonstration to them in an effort to try to win this contract because this is going to be a big, juicy contract with a lot of money on the line. So because there's like 400 different kinds of candy that they wanted, um, if we were to use conventional machine vision tools for that, we would have had to create, you know, dozens of different algorithms or even hundreds of different algorithms to identify every individual piece.
And then the training set would be huge too, right? If you were doing
Yeah,
training, yeah.
that's going to be big no matter what.
Yeah,
But
yeah.
like, let's say that you did not have machine learning. You just had conventional machine vision and you didn't have any neural networks or anything like that. You could conceivably still solve this problem. So you'd have to write software that would extract all of the visual information from every candy. And so you're probably going to want to look at like the major axis, like how long the candy is,
Yeah.
the minor axis, and then like you want to
The
know all
color.
are contained. And so
Yeah.
what I wanted was a color histogram.
Yeah.
So how many pixels fall within each color band?
Okay.
That's what I figured. Just me looking at it, that's the best way to identify these. Um, so you can do that, but then you have the programmer would somehow have to match these up to profiles of like 400 different candies.
Hmm.
And so, there's a whole lot of work there using conventional computer programming because you've got 400 different kinds and some look similar, some look other. And how do you program the logic for that? You say like, well, if it's longer than this, then it's probably a Twix. But does that always work? Or what are the good rules for defining what each candy
Yeah.
is?
Yeah, and then it's like a giant if statement or
Yeah.
case structure. Yeah.
So what I said was, forget this. I'm just going to create a neural network and I'm going to put in all of my different measured parameters, right? And then I'm going to give it a training set from images that I've actually taken from the actual candy, and then that will train the neural network. So it can find all of the different constants at all the different nodes of the network. And then it would just spit out an answer. And it would say, well, this one is most close to this kind of candy bar. So it took that portion of, we still had to do the work in extracting the visual information and choosing what information we wanted to put in the neural network. But then after that, it did all the hard work of trying to figure out what combinations of features match up well to each different candy. And so I did a proof of concept demonstration. They sent me a huge box of Halloween candy. Um, And when the project was done, my kids had a blast with that, by the way. They didn't want it back. And I was just like, my kids can eat it. They had candy that like it was like 10 times as much as normal Halloween, right? And so anyway, so they give this huge box of candy. There's thousands of candies. Um, it was really tedious. We took individual pictures of each one, and then we randomized like how they were presented, like what orientation. We got all the training data and the test data, and the end result was that the neural network that we created, every single image in the test set, we got the correct classification. So like it was so accurate, we didn't even know the limit of the accuracy, right?
Mhm.
And you know the test set was like I think it was like 500 or 1,000 images or something like this. Really cool. So that really built my faith in machine learning. Interestingly, we also dabbled using like a deep learning type of algorithm with this. So the difference there is that in deep learning, we just gave it the images where we didn't tell it what to look for. So we didn't tell them look at the length of the major axis, length of the minor axis, and the color histogram bins. We just said, here's the images. You try to as in the deep learning model, you figure out what you think is relevant here. I was unimpressed. So the deep learning model that we use was only 95% accurate,
Hmm.
right? And I think, of course, it is because it probably was like latching on to certain visual features that were not actually relevant, right? Um, and as a human being, I can look at this and I know exactly what is relevant and not. The length of the candy, the major axis, minor axis, and color histograms. So that's why I like to say that uh, artificial intelligence is great, but a combination of human intelligence and artificial intelligence, I think, is an even better combination for most applications. And a lot of times people are thinking like, I need some kind of like really powerful deep learning model, um, which those have their place. Maybe if you're Amazon and you're trying to analyze like millions of images, maybe that's what you want to use. But if it's like really fixed conditions with only certain objects, maybe a more simple approach would be simple machine learning with a single neural network and where the operator chooses exactly what data to send into the network. Yeah. So anyways, I get really excited about this, but
Yeah,
that's been my approach to artificial intelligence.
yeah. I took a class on machine learning and artificial intelligence probably 20 years ago now, and it covered some neural networks and support vector machines and a bunch of that type of stuff, and it was interesting. We had one application where it probably would have been very useful, but I couldn't ever convince anybody to do it. We were monitoring nuclear reactors for loose parts. So when they do service, they take the thing apart, and sometimes people drop wrenches and pipes and stuff in there, and or things break loose as it's running. And so they're always trying to figure out like what's rattling around and where it is, so that they can decide if they have to shut down or not. Because shutting down is like a big deal. And so we would collect all these things, and they were just like similar to your color histogram. They would just take the histogram of the frequency histogram of the rattling, and then try to identify it that way. And I was like, yeah, that'd be a great application for machine learning.
Yeah.
But nobody ever listened to me. I was just the low man on the.
Yeah,
So
it's really a shame because these neural networks, they can instantly do this enormous amount of analysis. And so the way I look at it is like in your case, they could put in, they perform like a frequency analysis and then
mhm.
divide that up into bins. And then each bin represents like the strength of the frequency band at that frequency.
Yep,
And then each one of those could be a factor in determining whether there's a problem or not.
yep,
So as a human developer, you could just try to analyze it yourself and try to recognize any patterns. But the neural network, it can take all of that information and it can instantly analyze every single one of those to see if there's a correlation toward toward the classification. And it also can analyze combinations. Like if
Yep.
there's two frequencies that when they're in tandem, that tends to correlate. And it can analyze combinations of the combinations,
Yep. And
right?
it could also analyze the time signal too.
Yeah, and you can put whatever data you think is
Yeah,
relevant.
yeah.
Put in time data or and anything else. I don't know, maybe temperature or
Location data. Yeah.
yeah. So it's analyzing all of the different combinations of data. And you can decide like how many layers you want in the neural network, like how much abstraction you want there. Um, and you have to do it wisely. You're not sometimes it's better not to have a larger neural network, maybe a smaller one. But it if a human being were to do all of that analysis, it would take an enormous amount of time. And you're probably going to overlook something. So uh, this is why I just have really fallen in love with machine learning. Now, truthfully, I have not dealt with a lot with deep learning. So it's all these young kids coming out of college. They're the ones that know a lot more about the deep learning and the large language models. I'm still trying to learn more about that and catch up. But as far as machine learning with just a single neural network, I feel very capable, and I have used that in projects before.
Yeah.
Yeah.
Yeah, there's another project that pops into my mind where we also could have used some probably this is probably more machine vision and not really learning much, but we had a circuit board tester and we had the flying probe that would move around and touch different points. And one of the challenges was mapping the board. So we'd get a new board and we'd have to put it in the fixture. We'd have to manually jog the probe to each point and like touch it and name it. And I always thought, why don't you just throw a camera on there and have it just detect all the solder joints? Because they're just circles. It should have been very easy to just do that and have it move right to there. And they could automatically center and I wouldn't have to sit there and like, oh no, I'm not quite in the center. Can I jog a little bit this way or that way?
Yeah, you're exactly right. That's a great application. And yeah, you could have put a camera on there, and I've done things like that before. So
Yeah.
a lot of times vision systems get overlooked. But many times you pop in a vision system and it makes a project easier. Vision systems, they are relatively difficult. It does take some know-how to do it. Um, when I get really scared is when there's complicated motion in the project. So, like someone will say something like, I have this product, like maybe it's these fingernail clippers right here, right? And they'll say, I just want to inspect the fingernail clippers to see if there's any scratches on it. And that's relatively straightforward. We just take images of each one, and then in software we can write some algorithms in order to look for the scratches. But then they'll say, oh, and I also want to check the bottom. And I'm like, well, how are we going to check the bottom if it's lying down on the table? Because it's obstructed. And they'll say, oh, no big deal. Just use a robot to flip it. Right. And I'm like, okay, you just multiplied the complexity by a factor of 3. Okay. And they're like, what do you mean? And I'm like, yeah, because like now we have to design a gripper that can grip it, and we have to locate where the part is so we can guide the robot to pick up the part and flip it. And I urge them, I'm like, let's try to find some creative ways to avoid having to flip the part, or maybe to flip the part in a way that's easier than using a robot, right?
Like have it fall off one belt onto another and it
Yeah,
like
there's
flips
little
as it
tricks.
falls. Yeah.
Yeah, there's tricks like that. Or another one I like to do is if it's moving on a conveyor, have it slide down like a glass slope, and then I can
Okay.
put cameras
Take a
on this.
picture. Yeah, yeah.
It's another little trick. All the listeners, there's a little free advice right there. So,
Yeah, I
um,
was thinking that too of like running it over something clear, but then do you have to worry about scratches in the glass itself? And
oh
how
yeah,
would,
if the
yeah,
glass,
that
yeah,
would be the
the glass
problem.
needs to be clean. So, there's some maintenance issues
Yeah,
there.
yeah.
Another one that doesn't require glass, and it depends on the geometry of the part, but you can actually have it pass over a gap between two conveyor belts, and then you can like squeeze in a camera or sometimes a line scan camera. And as
Okay.
long as as the part doesn't like fall down the gap, then sometimes you can image the bottom of it
I
that way.
wonder, could you have it go over something with a mirror and you could, and then somehow get a picture of both sides at once?
Oh yeah,
That would
mirrors.
be
Do
interesting.
cool stuff with mirrors. Oh yeah.
Yeah.
If you place a mirror really carefully, then that can simplify things in some situations. Or the other thing to do is sometime like what if you wanted to you had like a cylindrical object like this battery right here, and you wanted to inspect all the way around the battery, like all the label, right?
Hmm.
Well, a traditional way to do this would be to put it on some kind of roller system and then roll it around and take pictures while it's rolling. It's slow, it adds motion complexity.
Hmm.
Um, a better way to do this is to use a special 360-degree optic. Okay. So there are these attachments that you put onto your camera and it acts as the lens, but it's a lens and it also includes other things like mirrors and things like that.
Hmm.
And then when it and you would present it this way so that the camera is pointing straight down on the cylindrical object, and it'll take a picture of the top, but it'll also take a picture of all of the label all the way around the cylinder in one
Ah,
picture,
interesting.
one picture. And so now we don't have to rotate, we don't have to flip. It's just moving along, and we get one picture that has everything on it. The a great company that has 360-degree optics is Opto Engineering. Great company. I love those guys. Okay, I bought lots of stuff from them over time, and they're growing. So check that out, everybody. If you have a special imaging system or problem.
Yeah. Cool. No, these are all good stories. What other good stories do you have?
Oh boy, let's see. Okay. Um, this is a good one. So when I worked for Sciotex, they owned a special machine. They had invented this special machine that would count small objects as they're falling down like a little chute.
Hmm.
Uh, and the purpose of this was to count the objects as they were being packaged. And the way it worked is it had two cameras. So one camera would look at it kind of on the y-axis, the other camera on the x-axis, and then based on the two images, you could individually track all of the objects that were falling. And then it had filters too. And so like if if you were counting something like agricultural seeds, like maybe they were like corn kernels, and you wanted to fill up a bag with 10,000 corn kernels exactly. Well, you don't want to count it if the kernel is split in half or if it's just like a flake.
Hmm.
That shouldn't count. So they had all these these filters in place that would filter out all of that noise and everything. So very, very high tech, very, very accurate, and very fast too. So like as the parts are just cascading in, it's counting it up. So you could count like 10,000 objects, in a matter of a minute or two, depending on the size and some other factors, right? So that was really cool application of vision system, programmed in LabVIEW, by the way. But the uh, the things that people would contact us because they wanted to count the craziest things, okay? So I was bombarded with inbound phone calls of people who wanted to count marijuana seeds. It was like all anybody wanted to talk about was like, hey, does your machine count marijuana seeds? Right? And here I am, I'm like worried. I'm like, is this legal? Right? Uh,
Yeah.
like and I'm like, well, and then it didn't happen just one time. It was like five times in a row from different small like marijuana production companies, right? When certain states were beginning to legalize marijuana. So the thing that I hated about all of those inquiries is they never had money.
Oh.
That was the problem. They never had money. So they would say, "Oh, wow, this would be great because now I can automatically count these seeds." And then I would talk pricing with them and I'd tell them the truth, like this machine is tens of thousands of dollars. And they would all freak out. They'd be like, "What? How am I supposed to afford this thing?" And I'm like, Well, that's just what it costs, you know? Um,
That's actually cheaper than I was thinking, so I guess I'm a
yeah,
little bit better calibrated.
yeah, yeah. And so, like, normally I'd have this conversation with people and I'd say, we've got this great counting machine, and it's only this amount, and it was in the tens of thousands. For a lot of the customers we worked with, they would get a return on investment in just a couple months, you know?
Yeah, I
And we were
imagine
fine
those
with that
have.
because we were,
I imagine that at certain
yeah, go ahead.
applications, like certain. I think it's a matter of like economics. Like there's certain the price for certain applications it's way overpriced and it'll never work, but for other
Yep.
applications it's like it easily justifies itself. And there's a lot of things
Yeah.
like that I find.
And, yeah, talking business, we had some clients that said, well, it's a little expensive, but I'm going to get a return in 18 months or something. And so then it's kind of borderline, do I want to do it or do I not? And then we had some where it was just a slam dunk. So you had to price things strategically to try to capture, a good range of customers, but also
Yeah.
make sure that you're not losing your shirt on the deal. So,
Yeah, yeah.
uh,
Well, I also imagine a machine like that. There's like the hardware cost, and then there's also actually a machine like that. How was there? Is there a lot of setup for that and customization, or is it probably
oh,
putting in the filters, right? At
great
least.
question. Yeah, and so a lot of times the customers would need some customization with it, but usually it was relatively small. If there was some kind of customization, it was like they would want a different tray. Like it used a vibratory feeder, so they'd want a different vibratory feeding tray.
Uh,
And then after I left the company, they added in some special options that tended to help a broader array of customers. So like they have an option now where they can after you fill one bag, then there's an index machine that will index to the next bag.
okay.
That was something everybody was asking us for while I worked there.
Yeah, because they didn't want to have a person stand there moving bags. Yeah.
Yeah, and you don't want to have a human operator to kind of babysit it the whole time. Um, and then other things like they wanted to integrate it in with automated bagging machines. Right when I was leaving the company about 5 years ago, that's when um, that's when they were starting to do partnerships with those companies.
Yeah.
And my friends, my former coworkers, they're telling me that they're doing a lot of business that way. So if anybody's interested in automated counting machines, that's who you need to look for. Sciotex, not a paid advertisement.
Yeah. Well, I imagine another thing that popped into my head too is you mentioned like the corn kernels and stuff. Oh, you don't account if it's just a flake or a piece. I imagine there might be some way to have like a diverter somewhere that would send those off. I
Oh
know
yeah,
that might be way more complicated though, because then you've got
no,
motion and you got to track it and you got to make sure you divert the correct one. And
yeah, that was actually the first accessory that they designed over there. And so that had been in place for a long time. But yeah, the a diverter would go right underneath, and then it would have a pneumatic flapper that would flap back and forth.
hmm
But I can't remember. Yeah, with the geometry was more like this actually. And so if
yeah,
it turned this way, then it would fall in this way, and if it's turned this way, it would go in here. Um, Now, there's some limitations because if it has two fall at the same time,
yep. How do you? Yeah,
you can't really divert. So, and they may have made some improvements since I left. But yeah, that definitely was something people would ask for all the time. And then sometimes they would want some other customization. And so, we would add that in as as like another line item, like an
hmm
additional or some additional customization. So, but yeah, the other one that surprised me was this guy called in during right when the pandemic was starting, everybody was getting these pets, right? It because they were stuck in their houses, they all wanted like, well, let me get a cat, let me get a dog, and there were all these people that were getting these lizards, and the lizards needed lizard food. So what do they eat? They eat worms. So this guy had only just started this like lizard worm food like a couple years before the pandemic started, and it exploded. So he had like so many people wanting to buy these lizard worms, and he was having trouble because he wanted to drop like 5 worms.
hmm
We call them worms, but they might have been like caterpillars or
So
or
yeah, something. Yeah.
like this, right? He wanted to drop exactly 5 in each container. And he tried everything. He even tried like programming his own PLC with like some kind of like a photo eye detector or something
Hmm.
like that. And he couldn't figure it out. And we demoed, he calls us up and he's like, "Hey, can I ship you some worms to test it?" And I'm just like, whatever, I guess we can try it. Like live insects, it's going to be kind of weird. And what do you know? It actually worked. It worked. And like the first time we ran it through, we were kind of disappointed because like we ran it through and it was like sometimes it would accidentally drop 6 instead of 5. So we had some problems with the feeding. And the accuracy was pretty good, but it wasn't as good as we like it. We like it to be like 98% accurate. Um, and we did a lot of testing or we wanted it to be like 99 or
Hmm.
0.5%. It was only 98. So we came back and we apologized to him. We're like, yeah, we did some tests and it had some issues. But he was so excited. He was like,
Yeah.
what? He's like, you correctly and automatically packaged the correct number like 98% of the time. And he was just flabbergasted. And he was like, this is amazing. I love this product. And so he immediately bought one, and then we continued conversations, and he bought like a whole bunch more, and then his business just like exploded, right? And then after I left the company, I think that they started going to like uh like insect research conferences or something like this. And that machine has like caused like a huge tidal wave in like the way that insects are like researched and the way that like pet food is packaged and stuff. Like they totally disrupted that whole industry, just from this counting machine. And we weren't even thinking about, bugs when they were designing the thing, you know? And they actually made a special version of the product. The product's called Perfect Count, if you're interested. They made a special version that's just for insects. So pretty cool. We also did a whole lot of work for the Corel Dish Company. They're the ones that make the ceramic plates, the dishware, and they're known for having plates that are really thin. So they're lightweight. Really great company, high quality. They're made in America. So the dishes are made in a facility in upstate New York.
Is that
And
any connection to Corning then? Because Corning's
oh,
a big glassware. Is that why they're up there?
Corning owns Corel.
Okay, that makes sense then.
Yeah.
Perfect. Yeah.
Corning is like the larger company, and they own. And it's been a few years since I checked, or since I worked with them, but at least that's the way it was at the time. So we made an automated inspection system that would look for surface defects like scratches, imperfection, or if the silk screening was not correct. It also looked for warpage, like if the plate was warped in some way, and then also if the edge was too sharp. Because, if you're making a ceramic bowl, you don't want someone to put that up to his lips and then cut his lip,
Yeah. That
right?
makes sense.
So before we did the vision systems for them, we asked them, well, how are you inspecting them right now? And they said, oh, well, we just have an inspector will just run his finger along the bowl. And then I was like, well, we've got a problem because
Well, does he cut himself? Yeah.
right. And then have you had workers get cut? And they said, yeah, they started getting cut. So now we told them to wear gloves. And then I'm like, okay, well, when they're wearing gloves, can they feel if it's sharp? And they said, well, no, they can't really feel it very well. So I'm like, yeah, I'm like, you need to have a machine that measures this. So we ended up measuring the sharpness of the bowl and the warpage using laser surface profilers. They're also called laser triangulation profilers. And at first, before I joined the company, they were doing it like we were making our own laser surface scanners and just programming it in LabVIEW. Since then, there's companies that have come out, like LMI makes a great product called a GoCator that makes a 3D surface scan using lasers, and Keyence also makes really great ones too. And so all that can just be integrated into our LabVIEW code.
Yeah, I've used some Keyonce lasers for a few things. They're pretty good.
Yeah, Keon's is great. Um, I think Keon's is probably known for being the, top notch when it comes to vision systems. The other companies that are good are the LMI makes the Gocator. They're really great. And then, of course, Cognex is really great too. These companies, I love them and I hate them. Okay. I love them because they make really great products. I hate them because the way that their companies are set up, they don't really seem to be really nice to integrators. I'm used to National Instruments where they
Yeah.
set up alliance partner programs and provide training, and they seem to know how to work with integrators really well. Um, with Keyence, you basically just have to become friends with the salespeople, and then if they have an opportunity, maybe they'll call you. Uh, if if they need integration help. And then their controllers, typically you'll actually use their configuration software to create the
Hmm.
inspection, and then it gets uploaded onto the controller, as if it was a standalone,
Yeah.
it is a standalone controller. So you're not writing LabVIEW code uh, to it. Now, the way we tended to use those is that we would not deploy code to them. We would just tell them, transfer the image data to the PC, and then we'll do
Yeah.
it in.
Yeah, I remember the Keyonce instrument that I used, the LabVIEW driver was not very great.
Yeah. You know, the this kind of brings up a similar topic. Um, I was talking to another vision system engineer, but someone who does not have a background in LabVIEW. And when I mentioned to him that I'm a certified LabVIEW architect, he actually got really defensive and somewhat upset. And he looked at me like very negative views on LabVIEW, which is very weird because I have worked for many years and it seemed to me like LabVIEW has become accepted, and most people actually recognize that LabVIEW has a lot of power. But he seemed pretty upset because he said that the LabVIEW vision libraries were not very powerful. So I told him that I disagreed, and we had done many, many projects with LabVIEW Vision development module or Vision development module and done very, very complicated things. I did have to concede that, to my knowledge, I don't think very much change has happened in the NI Vision development module in the past 10 or 20 years. And so I was like, I got to hand it to you. But, when it comes to machine vision, the essentials of machine vision have not changed in 40 years, or 30 or 40 years. And so the only thing that I feel like the NI Vision development module is deficient in, and I'd be interested to talking to some NI engineers about this to see if I'm wrong. I don't think that they have very good 3D tools. So what I've always wanted in 2D, there's this concept called geometric match, where you do edge detection and then you try to match it up. You try to see if the two objects are matching each other after you've done the edge detection.
Hmm.
If they match geometries. I've wanted to have a 3D version of that. So rather than working with individual pixels, like 2D pixels, you'd work with 3D pixels. Sometimes they call them voxels.
Okay.
So I've wanted a voxel version of a geometric match. I don't think that exists in LabVIEW, but other tools have it. Like Keon's has it. Um, I was talking to some FANUC engineers. They make the FANUC robots. They have a vision system that goes with their robots, and they have 3D tools too. So if I were to encourage NI to do anything, it would be like, hey, can we add some more advanced 3D tools in with this?
Yeah,
Right.
that's a good request. I'm sure there are probably some NI people listening to this. Hopefully, the right ones.
Yeah. But so anyway, so there is some question about whether LabVIEW is so the biggest competitor, I think, right now is OpenCV, right? OpenCV is huge, and it's only getting bigger and bigger because Python is becoming more and more ubiquitous for integration, and especially with artificial intelligence. And I've used OpenCV, and I've it's a good tool and everything, but there are some things in OpenCV or that exist in the NI Vision development module that don't exist in OpenCV. And so in some ways, OpenCV is more rudimentary.
Hmm.
Um, but I guess the good thing is that it's free
Yeah.
and it has a bigger user base also.
Yeah, the licensing for the NI Vision thing, right? It's you pay for the development license, but then you also have a deployment license as well, which
Yeah, so
also,
that's
yeah,
another
that
strange
hurts.
thing too.
Yeah.
So, every single target that you launch your executable to, you got to pay, I I think it's around $500 or so.
Yeah, that's what I remember, something like that.
And that is, I guess the NI is trying to make their money somehow,
Yeah.
you know. And so that is something you have to factor in. But $500 I think is worth it, especially if you have a low number of targets.
Yeah.
And the great benefit, I think that you can develop code, including vision code in LabVIEW much faster than you can with other modalities or other languages.
Is that using something like the Vision Assistant? Is that what it's called? Where you can
Yeah.
like,
Vision
it's got like a
Assistant,
little GUI and you can drag and drop stuff?
yeah, very powerful tool. And so I will use the Vision Assistant a lot, and then sometimes I actually use the lower level Vision VIs that are part of the Vision development module if I just want to have a little more control.
Okay.
Yeah.
So when we're talking NI Vision, there's like NI Vision and the iMac, and there's a bunch of different stuff going on there, right? Is it all just one thing, or?
Oh boy, yeah, it gets a little confusing. Okay, so there is the Vision development module, and then that uh, includes all of your image processing algorithms and tools. So that's just for analysis of images. And then you have vision acquisition software, and that's used for acquiring the images from the cameras. And so within vision acquisition software, there's a few different drivers. So one is called iMac, NI-iMac. Now that is used for camera link cameras. So that's a specific communication standard or a camera standard. It's actually pretty old. I think it goes back to the 90s. But camera link is still used today, and it still is very powerful. It's a it's a um, it's a specific protocol that uses parallel digital communication. Um, then there's iMac DX, and iMac DX covers other types of cameras like USB cameras, Ethernet cameras. I
Firewire maybe, or Thunderbolt, or
Fire.
some of
Oh yeah,
those. The
Firewire. That's old. Yeah,
Yeah,
Firewire.
Firewire is really old.
I think it's still included. I have to check to see if the new versions still support Firewire. And I do have to check because it hasn't come up in my work yet. But there I think that the new versions of iMac DX might support Coax Express. Don't quote me on that because never had to use it before. Um, but and every one of those has a specific camera standard. So like the USB one is called USB Revision, and the Ethernet one is called Gigi Vision. And so all of those are encapsulated within iMac DX. Um, and then there's another driver that you can actually use with Vision FPGA applications. Okay. Um, so those are the different drivers. Now it gets a little tricky because sometimes some of the functions in the Vision development module will contain the word iMac.
Ah, okay.
So it's a little tricky because you're like, is this part of the driver, the camera driver, or is this part of the Vision development module? The boundary gets a little bit blurred sometimes. So um, I think that's what the confusion stems from. Yeah. Now the Vision, both of those modules you have to pay for.
Hmm.
Um, the with some exceptions, and I have to check because it's been a few years. But I think that if you do I think that the NI iMac driver might be freely available, and if you're using camera link cameras. So check with NI to find out the pricing and the costs of everything.
Okay. So, wrapping things up, I always like to ask people about experiments, and you had mentioned one that had to do with automobile hubcaps. Do you want to talk about that?
Oh yeah. Well, so I'm interested in just improving my skills, and there was a couple years ago, I decided that I wanted to try to get some more practice with vision systems, especially in machine learning and with LabVIEW, and then also Python too. And so I found this website that people can upload image data sets. I honestly I can't remember the name of the website off the top of my head, but they'll upload these image data sets and they will allow developers just to experiment with these. And so I downloaded one that had hundreds of images of automobile hubcaps, and some of them were cracked, right? Oh, and then that's right. This one was for a contest. I forgot. So I was trying to compete in this contest to see, uh, if I could develop an algorithm that was superior to everyone else's. Well, then I had this idea. Most people are probably just putting this through some kind of like a deep learning algorithm, or maybe they're even using some like a lower level, like a machine learning. And I decided, no, I'm gonna go old school on this. No AI, just conventional machine vision. But I'm gonna use a special algorithm that I learned in college, that was called active contour. So what I realized is that good hubcaps are a perfect circle. Bad hubcaps have cracks in it, right? So this active contour technique, what it does is that you create this circle that is defined by individual nodes that are connected to each other, and it makes this ring. And so this this entity that exists as interconnected uh, nodes, it forms like a ring or a line. So they call that a snake. Okay. And each one of the nodes, they call that a snaxle. Okay. Because it's like a snake pixel.
Yeah,
Okay.
yeah.
Right. And then the idea is that these exist at different points in the image. And then the conditions on the image around each individual snaxle, those will actually create a force on the snaxle that will force it to go in a certain direction. So if, like, let's say that you want the snake to gravitate more toward a darker area of the image, then you would tell it that put some kind of like a magnetic force so that darker portions of the image will pull on it, you
Hmm.
know? And so you define all these forces that act on the snaxles. And then the idea is that once it reaches some kind of edge, that the forces are going to balance out perfectly, and it's just kind of rest on that edge. So you start out with the snake that's in a ring shape from the outside of the image, and then it just naturally gets pulled into the middle.
Hmm.
So the end result is that it's a special kind of edge detection algorithm, but it's very powerful, right? Well, I had a blast doing this, and I was like really getting into this and defining the forces and everything like this. But the I realized that it just was like a lot harder than I thought it was going to be, and I ended up spending a lot of time. It's like almost like I was inventing an entire new like LabVIEW library that didn't
Hmm.
exist before, and I ran out of time and I even never even submitted it, right? So I looking back on it, it was kind of cool that I invented this kind of new thing, or I was trying. I didn't invent it. Active Contour had been around, but I was trying to apply it in a new way that I don't think is used in LabVIEW very often. In the end, looking back on it, I should have just I should have just done it the same way as everybody else. I should have just done some kind of like neural network and put in parameters or something like this and submitted it, because you really have to manage your resources, and time is a resource, right?
Yeah, that's a very interesting lesson to take from that. Looking at the outside, I would look at what was the goal of the whole thing.
Very good
So,
point.
so if your goal is actually to complete the exercise, then yes,
Right,
I think your lesson is dead on.
right, right.
Or
So
if you're using that as a learning experience, oh, I learned something new. And then my question to you would be, when you were done, could you take that Snaxel or algorithm and use it on something else? And were you able to do that?
yeah, great question. So that did happen a few years ago, and I have not gone back and reused that library. And it just didn't work quite as well as I wanted it to, and I wanted to polish it up some more. I guess if I do ever have time, it would be really cool to polish it, and it would be cool to share it with the LabVIEW
Yeah.
community and say, here's a special kind of image algorithm that works in a totally different way than the normal edge detection algorithms,
Yeah.
and it has advantages and disadvantages, and that'd be cool if the LabVIEW community could see that.
Yeah, well, I that whole discussion stems from me being somebody who likes to go down those rabbit holes and chase those things down,
Yeah,
and then, but what I've learned over the years is sometimes I go and I chase those down just for like the pure curiosity of it, and those tend to not work out quite so well, or just in the sense that like, okay, I build something, it's kind of cool, but then I end up just like leaving it because it's like I don't have an immediate use case for it, and I
right.
feel like I do far more better when I have, like, if I have an actual paying job. Oftentimes it works really well if you have a paying job where it's really large, and then so then like the exploration is a really tiny percentage of the entire job, and then it works out really well, and then I go experiment and
Yeah,
I go try things. I'm like, and if it doesn't work out, it doesn't kill the job because it's a small part of a giant job.
absolutely.
Yeah.
And I totally agree. And I've said the same kind of thing for years. In fact, one of my mentors was Michael Coleman. He was the one that owned the Coleman Technologies before it was the name changed to Sciotex. So he used to always tell me the best way to learn a new technical skill is to get paid for it. And I thought, well, that's pretty presumptuous because how are you going to get someone to pay you if you don't already know it? And then he said, work on a project where you know how to do 70% of the things, but you don't know how to do 30%. And then that your skills are going to improve a lot doing that. So, I guess if this that project had been a paid project, I certainly would have finished it and polished it up a lot better, and possibly even, pushed it out to the LabVIEW community, and other people could have played with it.
Yeah.
Um,
Well, I feel like too, we don't do enough just playing and practicing, I think. Like other, like, right, like professional athletes, they perform very little. Like they spend most of their time practicing. And professional software engineers, we spend all our time doing and very little time, if any, practicing.
mhm.
And sometimes I feel like there is a freeing thing in the practice part of it, at least in that there's no pressure, right? Whether
Right.
it succeeds or fails, it doesn't matter. Whether you get done in time, like if you're doing something just for the sake of learning, it's all about what you learn, and the outcome of like whether it works or not has very little bearing.
Right. Absolutely.
Yeah.
Yeah.
But also, like as somebody who's self-employed, I could spend a lot of time doing that, and then I wouldn't make any money. So I also have to
Yeah.
like balance that part out as
Yeah.
well.
You got to pay
Yeah.
the bills, and
Yeah.
self-improvement is something you factor into your schedule and your cost and your needs. You
Yeah.
know, one tool that I've used in my self-improvement is, um, let's say I want to learn about a topic and I'm not going to get paid for it. I'll still treat it like a project. So I'll still give myself specifications, and maybe I'll just do it in a different way that I'm used to. Like I feel really comfortable in LabVIEW, but not as comfortable in Python. So I'll take one of my previous LabVIEW projects and I'll just do it over again in Python.
Yeah.
Right.
Do you experiment at all with the advent of code? Have you done any of those? Do you know what that
Advent?
is? Yeah,
No.
there's this advent of code thing that happens So I may have just ruined your entire like month of December, but basically it's like advent calendars, right? You start in December and every day, as a kid, you would like get a calendar and open it up and you get a piece of chocolate. Advent of Code is a coding challenge, and so every day in December they give you a coding challenge.
That's
And
cool.
it's interesting in a couple of ways. One, each problem has two parts. So they describe the problem, and they give you some samples, so you can like do the whole test-driven development thing if you want. But they give you some examples, and you write the test, you write the code, it passes. That's great. And then they give you a second part, which is very interesting because sometimes it expands in the way that you're thinking, and sometimes it goes in a completely different direction, which is really challenging. But to this conversation, some of the things are interesting. They're not none of them are image processing stuff, but some of them you could visualize them very well as images. And so it would be very interesting to if you had a natural like vision approach, like some of it's like walking mazes and stuff. And so
Hmm.
like, you know, yeah, there's probably an algorithmic approach, but there might also be some kind of vision approach of like, okay, let me draw what I think is a snapshot of this thing and then use a vision algorithm to figure out the best way or something.
That's so cool. Yeah, I'm definitely going to check that out. It also because an interesting pattern that I've noticed after working in consulting for so many years is that the first 3 quarters of the year, work tends to be relatively steady, and so I'll have people reaching out to me and we'll talk about projects and other things. And then the last quarter, sales are always so nobody wants to talk about a new project in like November and December, you know? And
Last,
then
yeah,
January comes up and suddenly like everyone gets back from their vacations and for Christmas and then my it's like my phone's off the hook. Everybody wants to call and talk to me about projects.
yeah, I do definitely notice an uptick in January because people start planning for the new year. They do all their planning in January. The end of the year is interesting. So sometimes I have projects that they just want them done by the end of the year for whatever reason. And
Hmm.
sometimes that's a good reason, and sometimes it's just like, wow, we just need to close our books. And
Right.
the whole like, every time somebody gives you a deadline, like ask them what happens if you miss it, because
Hmm.
sometimes it's nothing. But then the other thing I get too sometimes at the end of the year is people want to do training because they have a training budget and they get to like November and they're like, oh, we haven't spent our training budget and it runs out at the end of the year. And oh, what are we going to do with that? So sometimes there's some interesting stuff with that.
Yeah, interesting. So I guess sometimes December is really busy,
Yeah,
but it's usually projects can be busy, but I my experience is that sales are low. Like
yeah, definitely no sales inquiries, no leads are coming in. Yeah.
yeah, you're not going to get leads. In fact, when I worked at Sciotex, we kind of noticed this pattern. So I went back through our records and I proved it. So like the average number of leads was measurably lower during the
Yeah.
last quarter of the year.
Pretty
Yeah.
much after like middle of November, like once you hit people are starting to think about Thanksgiving, it's like it's over.
Yeah.
Yeah.
Nobody wants to talk about projects.
Yeah.
So interesting patterns, right?
Yeah. No, it's good to notice those patterns and pay attention and just kind of play around. The thing I noticed working at a big company is a lot of when I would have ideas for projects, I would go to my boss, be like, "Oh, great, we should do this," and they'd be like, "Oh, well, we just missed the budgeting window, blah 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 blah," and it was never. So a lot of it just is timing in terms of budgeting, and a lot of companies do the January to January thing, but some of them don't. So if you have an inside person who can tell you those things, that's actually quite useful. So it
Right.
goes to having like a good relationship with your customers and trying to get them to open up. But sometimes, like when I was an engineer at Westinghouse, I honestly didn't know when the budgeting process was. My boss was not very good at communicating that, and I was just like, I was dumb head down engineer, just like give me things to do and I'll go do them, and I wasn't thinking that far ahead. So
Yeah, yeah. So, the one thing I've noticed too in doing consulting is that there's tends to be a long lead time from when you first start talking to somebody about a project before you actually start it. And then the larger the project, the larger the lead time too.
yeah, that is definitely true. Yeah, when I start talking to somebody, very rarely is it unless it's like an emergency and it's like a small project that then sometimes those things like happen pretty
Yeah.
quickly, like a week or two. But generally, it's like yeah, I know when I start talking to somebody, it's going to be at least a month before
Yeah.
anything actually happens usually.
Yeah.
And
Yeah.
then also depending on payment terms, it's going to be at least another month or two until you get paid. So that's
Oh,
always
yeah.
like yeah. So,
Oh yeah.
so cash flow and being cognizant of that and being good at savings is good for being self-employed.
We've had times working, and interestingly, this is with some big corporations. You'd be surprised. I'm not going to say names, but big corporations that sometimes would not pay us for like 6 to 8 months. And it
Uh,
drove me
yep.
nuts. It drove everyone in my whole company nuts,
Yeah,
right?
I could say there's at least one company that we've mentioned several times here who their default payment terms are like 90 days. And I'm just like, really?
Yeah.
Like,
This particular company wanted they wanted like 120-day
yeah.
net 120.
Yeah.
And we're like, we can't do that. Like that's so much time. And so they didn't finally we agreed, like, we'll go ahead and do it just because we need the money. But they wouldn't pay it after 120 days. They waited like 240 days to pay it.
I've had several companies like that where it's like they say the terms are net whatever,
And
and until you hit like, so say it's net 45, until you hit day 46, you don't know they're not going to pay it. And then
yeah,
you inquire on day 46 and like, well, we never got it. So go submit it again. And it'll go in the next round.
yeah.
And then you have to wait another 45 days. And they're like, yeah, that,
So I really love being a freelance uh, developer and consultant. It's a lot of fun, but you know, if anybody's out there thinking about going freelance, these are the kinds of things you got to deal with, you know.
the best advice I have is have a spouse who has a good job with health insurance. If you got that, then it's all, although it's double-edged sword, right? Because my wife did work, and when she was working, I was running my own business. Like there was no fire under my ass to like do stuff, and I was there was a lot of like, oh, I can take off in the middle of the week and go rock climbing and do all this stuff, and it worked. But then when she decided to stay home with our kids, it was there was a new fire at that point,
Right,
and
a
then it
new
became
fire.
much more serious. So
Yeah.
yeah,
This has been awesome, Sam. I've
yeah,
had
it's been a great conversation. Yeah, I think
a combo. Yeah.
we should
Well,
definitely wrap things up. It's been a while, been long
yeah.
enough. Yeah,
I just wanted to tell everybody out there that's listening. So my company is Optozilla LLC, and if you want to look more about the kinds of things that I've done since I've started my own company, you can check out optozilla.com.
yep. And you're also on LinkedIn because I know we're
And I'm
friends on
active on
LinkedIn. Yeah,
LinkedIn.
yeah,
Absolutely. Anybody who wants to connect me on LinkedIn, just send me an invite.
perfect. All right. Well, thank you very much.
Okay. Take care. Bye bye.
That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram at the LV Experiment.